Hi, I am Arib. You are watching my YouTube channel. 132 kV grid station complete explanation. Definition. A 132 kV substation plays a crucial role in the power transmission and distribution system. It serves as a hub for receiving high-voltage electricity from generating stations, stepping it down to lower voltages for distribution to industries, commercial centers, and residential areas. The 132 kV voltage level is commonly used in many countries as part of the high-voltage transmission network, providing a balance between transmission efficiency and safety. Role of a 132 kV substation in power systems. Substation is a key element in an electrical power system, enabling the transmission and distribution of electrical power from generating stations to consumers. The primary function of a 132 kV substation is to step down the voltage from high transmission levels, such as to 20 kV or 400 kV, to a more manageable level, 132 kV, which can then be further stepped down for local distribution. 33 kV, 11 kV, etc. This transformation is essential to maintain the efficiency of power transmission and distribution over long distances while ensuring the safe and reliable supply of electricity. A 132 kV substation generally operates at extra high voltage (EHV) or high voltage (HV), serving as an intermediate node in the power grid to reduce power losses, regulate voltage, and manage power distribution. Types of 132 kV substations. 132 kV substations can be classified into different categories based on their design, construction, and function. Air-insulated substation, AIS. In an AIS, the high-voltage equipment is installed outdoors, and air acts as the primary insulation between live parts and grounded structures. These substations are widely used due to their lower cost, simpler construction, and ease of maintenance. Advantages: lower cost, easy to expand, and simpler design. Disadvantages: requires more space and may be affected by weather conditions such as dust, rain, and pollution. Gas-insulated substation, GIS. A GIS is a more compact and enclosed type of substation, where the primary equipment is insulated using sulfur hexafluoride SF6 gas. This design reduces the size of the substation and makes it suitable for urban and high-density areas where space is limited. Advantages: compact design, reduced footprint, and minimal environmental impact. Disadvantages: higher initial cost and more complex maintenance due to gas-insulated equipment. Hybrid substations. Hybrid substations combine both AIS and GIS elements, offering flexibility in design and cost. This type is often used when some equipment needs to be compact, example, transformers, while others, example, circuit breakers, can be installed outdoors. Components of a 132 kV substation. A 132 kV substation consists of various electrical equipment designed to transform, control, and protect the electrical power within the system. The key components include: power transformer. The power transformer is the heart of any substation. In a 132 kV substation, transformers step down the incoming voltage from higher transmission levels, example, to 20 kV or 400 kV, to 132 kV. The transformer has high efficiency and is designed to operate continuously over long periods. Tap changer. regulates the voltage within permissible limits by adjusting transformer windings. Cooling systems, oil or air cooling systems ensure that the transformer doesn't overheat during operation. Circuit breakers. Circuit breakers are crucial for controlling and protecting the electrical equipment in the substation. They can disconnect the power supply in case of faults such as overcurrent, short circuits, or system abnormalities. In a 132 kV substation, circuit breakers may include SF6 circuit breaker, uses sulfur hexafluoride gas for arc extinguishing during fault conditions. Vacuum circuit breaker, VCB, uses a vacuum to interrupt current and is generally used for medium voltage but can be applied at 132 kV in certain designs. Isolators, disconnectors. Isolators are used to ensure a section of the circuit is completely de-energized for maintenance. Unlike circuit breakers, isolators do not interrupt current flow but are operated under no-load conditions to ensure personal safety. Current transformers, CTs, and voltage transformers, VTs. These transformers are used to step down current and voltage from high values in the primary transmission line to lower levels for metering, protection, and control equipment. CTs and VTs ensure safe and accurate monitoring of the substation's electrical parameters. CT provides a proportional low current for relays and meters. VT or PT steps down the voltage for protection and metering purposes. Bus bars. Bus bars are conductive bars that distribute power from incoming transmission lines to various outgoing circuits within the substation. They are designed to handle large amounts of current and are insulated for safety. Types of bus bar configurations in 132 kV substations include single bus bar, simple and cost-effective, but has no redundancy. Double bus bar provides redundancy and allows for maintenance without complete shutdown. Protection and control systems. The protection system in a 132 kV substation includes relays, fuses, and other protective devices that detect abnormalities like overcurrent, earth faults, and short circuits, and initiate the tripping of circuit breakers to isolate the faulted sections. Relays automatically detect faults and send signals to trip the relevant circuit breakers. SCADA systems, supervisory control and data acquisition. SCADA systems allow remote monitoring and control of substation operations, improving reliability and response time. Earthing system. The earthing system ensures that any fault currents or leakage currents are safely discharged into the ground. Proper earthing is critical for protecting both equipment and personnel from electrical shock and damage. Surge arresters. Surge arresters protect the substation equipment from voltage spikes caused by lightning or switching operations. These devices absorb and divert excess energy to the ground, preventing damage to sensitive equipment like transformers and circuit breakers. Working of a 132 kV substation. A typical 132 kV substation works as an intermediary node that receives power from higher voltage transmission lines, steps down the voltage, and distributes it to lower voltage networks. Here's a simplified workflow. Power reception. High voltage power, example, 220 kV or 400 kV, enters the substation through incoming transmission lines. Surge arresters protect the system from voltage spikes, and circuit breakers and isolators ensure that incoming lines can be safely controlled and isolated. Voltage step down. The power transformer steps down the incoming voltage to 132 kV for distribution to lower voltage substations. Transformers are fitted with tap changers to regulate voltage levels based on load variations. Bus bar distribution. The power is distributed via bus bars to various outgoing circuits. Protection systems monitor the current and voltage, and in case of any faults, the circuit breakers are triggered to isolate the fault. Outgoing power distribution. Power is sent out to either 132 kV transmission lines or further stepped down to lower voltage levels, 33 kV, 11 kV, for regional or local distribution. Control and monitoring. The SCADA system allows real-time monitoring and control of the substation, ensuring operational efficiency and rapid fault detection. Protection schemes in 132 kV substations. The protection of a 132 kV substation is critical for ensuring system stability, preventing damage, and ensuring the safety of both personnel and equipment. Key protection schemes include: differential protection monitors the difference in current entering and leaving a section of the substation. Any imbalance indicates a fault. Overcurrent protection protects against excessive current caused by short circuits or overloads. Distance protection used in transmission lines to measure the impedance between the substation and the fault location. If the impedance drops below a threshold, the relay trips the breaker. Earth fault protection detects leakage currents to the ground and isolates the faulty section.